Hello and welcome to the Reigate College Further Maths video where we will be looking at definitions of work and energy. So work is done by a force when it causes an object to move. It's measured in joules or it can also be measured in Newton meters. And it's defined as, work is defined as force times distance. If the force is in the same direction, if the motion is in the same direction rather, then the work is just force times distance. So if we have a block with a force like that, then the work done would be the force times the distance moved by the object, but sometimes the force is applied at an angle. So if the force was applied at an angle like that, then we would resolve the force. So we'd have F cos theta and would multiply by the distance moved by the object in order to find the work done. We sometimes also speak of work done against gravity. This is mgh, and a way of thinking of this is the force you have to apply to overcome the weight of the object multiplied by the perpendicular distance upwards. This is the vertical distance that you move it. So let's have a look at a couple of questions. Here we've got a packing case pulled across a horizontal floor by a horizontal rope. So the case moves at a constant speed. As soon as you see that word constant speed, you know that the net force is 0. And there is a constant resistance of R newtons. When it has moved 12 meters, the work done is 96 joules. So we're going to start off with a very simple diagram just to make sure we get everything in the right place. We've got a force of T acting in this direction, and there is a resistive force R acting in that direction. And we know that T is equal to R because of this constant speed. We also know that work done is the force multiplied by the distance. So in this case, we've got 96 as the work done is equal to the force, which we know is T, which is equal to R. So I'm just going to write R multiplied by the distance, which is 12. So R must be equal to 8 newtons. So that's a fairly straightforward question where we just need to draw the diagram, mark on the forces, note that it's going at constant speed, and use our definition of work done. Question 2. Again, read the question through and draw a diagram. A truck is pulled along a smooth horizontal track, and this time the force is 150 newtons and it's inclined at 60 degrees. So here we've got our truck, and there is the force of 150 newtons inclined at 60 degrees. So we've got our diagram looking like that. It's a smooth horizontal track, so there's no force resisting, and we're told the work done. Find the distance moved by the truck. So what we need to think is what's the force in the horizontal distance, in the distance, the direction of motion. So we need to say 150 cos 60, that's the resolved force, multiplied by the distance s, and be careful when you write your s that it doesn't look like a 5, and that is equal to 375. Cos 60 is a half, so we've got 75, s is 375, so s, in this case somewhat ironically, is equal to 5 meters. So this has been moved a distance of 5 meters. The last question is on an inclined plane. There's not really quite enough space for this question, so I'm going to use some extra paper. So what we've got here is a box pulled up an inclined plane by a tractive force. A tractive force just means it's pulling parallel to the slope, and we know the coefficient of friction between the box and the plane. So we're going to start off with a diagram. So our diagram here, it's a little bit steep actually, never mind. So that's 30 degrees. We've got a box on the plane. So the box has a mass of 15, so a weight of 15 g. It's pulled up the slope by a force, and we're going to call that T. Now, it's moving at a constant speed. So because it's moving at a constant speed, we're going to have the reaction force there, but here we're going to have mu r. We know that it's going to be limiting equilibrium because it's actually in motion. So let's have a look at what we're asked to do. First of all, calculate the work done against gravity. So the work done against gravity, we need to look at that's going to be mgh. So we need to find the distance, the vertical distance that it's moved. So we use some simple trigonometry for that. We know that it's moved 8 meters up the slope, and we want to know that distance x. So we're going to say that sine 30 multiplied by 8 is equal to x. And so that's the height that's moved. So to work out the answer to A, the work done against gravity, this will be m multiplied by g, which was 9.8, multiplied by 8 sine 30, which is the height, so that's the vertical height that it's moved, and that comes out to be 588 joules. So that's the work done by the force against gravity. Part B of this question asks you to work out the tractive force. So we're going to need to resolve some forces on the slope in order to work this out. So let's start off by resolving perpendicular to the slope. So that symbol there means that we're resolving perpendicular to the slope, and we've got R pushing away from the slope is equal to 15g cos 30. So if this angle here is 30, then that angle there is 30. So this is going to be 15g cos 30. And that is equal to 127.3057. We're going to, remember, you need to use the full value in subsequent working, but we haven't answered this question yet. We're trying to find the tractive force. We know that it's moving at constant speed. So we know that the forces up the slope are equal to 0. So we're going to resolve parallel to the slope. And what we've got is T acting up the slope minus 15g sine theta, sine 30, acting down the slope, minus mu r, which is 0.4 in this question, multiplied by r, and we know that that is equal to 0. Putting the values in here that we've got, so we're going to substitute in that 127.3057. This gives you that T is 124.4. However, mechanics questions, we're always going to give our answers to 2 or 3 significant figures at most. So we would say that the tractive force is 124 newtons. Then calculate the work done against friction. So the work done against friction is the force that we've had to apply to overcome this mu r. So the work done against friction for part C against friction is going to be mu r multiplied by 8, which is going to be 0.4 multiplied by 127.3057 multiplied by 8, and that gives you a final answer of 400 and 7 joules when we round to 3 significant figures. So that's the work done against friction. So this force has done 2 lots of work. It's done work done against friction and the work done against gravity.